Hi, everyone. Welcome to episode 9 of the Exoskeletons and Wearable Robotics podcast. I'm your host, Bobby Marginov, and with me is Professor Tom Sugar, and we have a very special guest today, George Woodland. Before we start this episode, Military Exoskeletons in the Field, I would like to thank our Patreon subscribers, Rita Vasquez Torres, Volker Bartenbach, and Josh Capuro from Humotech. Thank you for your support and making this podcast possible. Please check out our Patreon page. We will appreciate any membership level. So, hi, Tom. Hi, George. How are you guys doing today?
Doing well, thank you.
Yep, doing well, Bobby. Thank you for asking.
Well, you are our very first guest on the podcast, and we are very lucky to have you here with us. So, for those who don't know George has 13 years of experience in the field with the Canadian Armed Forces. He's also had 3 years of biomedical and medical engineering studies, and an additional 3 years of experience in the field, in the industry field with analytical technology. So, George, you're a really unique individual. We don't get to see people like this every day. You've had the field experience and you've had the engineering and bioengineering background.
Oh, and thank you, Bobby. Yes, I'm lucky to have that and to push myself, honestly. And I kind of want to thank people like Tom for being that kind of inspiration as well. People like you making the technology and studying the technology. Sorry, let me introduce myself. My name is George Woodland. I'm the former Canadian Armed Forces soldier, and Bobby was right. I do have several years experience in biomedical technologies as well as field technician work. In the military, I was a soldier working on Leopard tanks, and before that, I was an infantryman with the reserves. Actually, Bobby, I've known since 2016, even earlier. And after I got injured horribly in an accident with a vehicle, a tank turret actually, and that kind of ended my military career. So that kind of brings the view that I have coming from the ground up to the engineering perspective of the end user devices. So people like Tom and people like Bobby who bring to light on this technology that we're reviewing today, so exoskeletons. But when the product is produced, what then now? What are we looking for the support, and how is that technology being adopted in the field? So to make this not a waste of money and time and manpower using new technology. And Tom, Bobby, you probably know this better than anyone. When the military adopts technology, a lot of times it gets very rushed. Certain weapons platforms, I can think of a notable one would be the M14. Was very much rushed in and was quickly taken out of service in 1 year, and that led into the adoption of the U.S. military going with M16. So how can an exoskeleton technology getting adopted by the military avoid that kind of instance? And that would be coming to where we're at and being adopted now, of being on the front lines or being combat soldier. You are looking at a variety of threats that you'll have to deal with, and a number of pieces of equipment that you have to bring to that fight if it's available. If you're in the infantry, obviously you've seen images of individuals wearing helmets, body armor, rifles, boots, but no one sees like the minor things you have to carry: your GPS, your compass, your map, food, your rations, what kind of metabolic rate, and what kind of environments that person's going to be in. Now, humans are very adaptable creatures, and Tom, you know this. And warfare does change, but the one thing the U.S. military has always succeeded the most in is their logistics and how to get the supplies to the front line as quickly and readily as I can. And that's partly where I see exoskeletons coming into play. Is not just in the logistics, but the maintenance of certain systems like tanks, armored vehicles, aircraft. Sarkos Robotics, when they were actually, Bobby, you had a very amazing article on that, on the Exos one, and then the development of.
Yeah, they were working on the Guardian, which is the full body suit.
Yeah. So even the Exos 2, when I seen everyone was talking about wanting to go to a mobile non-tethered system.
Right.
So not a lot of people know this, but there's a receptacle on tanks. They're usually in the back by the engine. It's an output and then the input would go to another vehicle, and that provides enough current and voltage. It's a large jumper cable, but the thing is, you can also run additional supplies. So if you want to run a generator or another engine, you can run it directly off the vehicle. This is something I can see where exoskeletons will be heading to, is that if you are going to be using exoskeletons in the field, this is where you can start hardlining them to vehicles, providing a larger power output, potentially giving you that ratio that you're looking for, that 1 to 7 pound ratio, where that one, wherever it's 7 pounds, but it feels like 1. Tom, you have a lot of experience with military exoskeletons and the applications, the demand as well.
Yeah, we were looking at some back exoskeletons at the hips, and we were thinking about, again, in this logistics area where you could assist soldiers in moving heavy equipment. So for an example, we were looking at working with aerial porters about building some hip exoskeletons to push very large pieces of cargo onto planes.
Right.
Yes, you could have large equipment get the cargo to the plane, but someone's got to push it inside the plane. And so there's always these, and you could probably give us some examples in this area. There's always these things where, yes, you can use motorized equipment. Yes, you could use fork trucks, forklifts, and do things. But there's those times where, there's that last bit of that you gotta use just human
manpower. Yeah, you just got to use, you just got to have the boots in the ground, or you just got to use your backs and arms to get the cargo. I've been there, especially when we have to start loading and unloading trucks and vehicles in the most austere conditions without any real organization. So I'm not too familiar how the armored lines work with the United States military, but for the Canadian military, what we do is that we'll have what's called a running replan, or running replenishment. So we'll have our line of vehicles parked out in a designated area where our column of tanks will come by to get fuel, other consumables like oil, coolant, hydraulic fluid. We'll have water available as well. This is where, and also the one important thing about this running replenishment line, this line of administrative vehicles, is that every one of the individuals that are inside that administrative line are also tankers and armored crewmen, so that in the event that something happens, you have to switch out individuals in the vehicle. So someone who's driving a tank who's injured, and they have to switch that individual out. Person that's in the replenishment line can jump inside of that vehicle because they're already trained to do so. And the other thing about this replenishment line is that we do have maintenance areas. The maintenance areas are where you'll usually find what's called an armor recovery vehicle for an RF. Now, the armor recovery vehicles, you have a crane, you have all the replacement parts, and then you have the manpower that's there to do the maintenance. On a Leopard 2A6, the track is roughly 3 tons, and that's for the entire road. Each section of track, and I mean like each small section, you're looking at about 150, 200 pounds. It's a lot of weight. It's a lot of manual labor to replace track on a vehicle. And let's not talk about the other ancillaries like the add-on armor packages, the radio equipment, the other engine compartments. And since the armor recovery vehicle does have these input-output receptacles, having an exoskeleton tethered to an armor recovery vehicle makes work in austere conditions with heavy equipment. And this is just an example. On the front of a Leopard 2 A4 Can-Am, the Canadian version, we have an added mine package. There's it's about a 3 foot by 2 foot block. We need 4 people to pick that thing up and to get it mounted.
Right.
The 5th one is usually the one screwing the bolts in. So it's giving you a perspective of how heavy this equipment in the field. But the issue that I can see running into exoskeletons is neglect. Neglect's huge. You're going to find stuff in the front lines that's been left there, abandoned and damaged by the elements or by the how can you replace that? Is it easy enough for in-field use fixes? And and also what's the temperature rate on some of this equipment? Because I've woken up with ice on my sleeping bag, and I've woken up with more with a lot of loss of body weight just from water because it was that hot. So helping exoskeletons work in these kind of conditions as well. Like we've already seen Lockheed Martin's. Did Lockheed Martin get that? Borrow that technology from Temia from Canada, by chance?
Yeah.
Yeah. So
Yeah, they did, but I don't believe that they're currently working on any of it. So Lockheed Martin's both advertised exoskeletons were projects done with another company. So there was technology from Vitamia and there was technology that was in line similar to what things were being done on the West Coast through different projects. But this is where Tom and I think a lot of our listeners have a blind sight. Like, can you run us through like this example of the M14, M16? What happens to equipment that is in the field in field conditions? And also, what is the availability of support tools and aids? Because I see it as a double-sided sword. On the one hand, you could benefit more from exoskeletons because you're missing equipment, you're in the field. But on the other hand, there's also lack to engineers and support. Can you run us through that a little bit?
Right. So the issue with the M14 was that it was going into a combat area where a number of enemy troops were carrying the AKs and AKMs. The AK-47 had about 13 years to mature with the Soviet military and its allies. The M14 was coming in as a potential solution for the U.S. military's weapons logistics. So trying to reduce the amount of weapons down to one system, but didn't deliver that. And some of the conditions that that weapon was going into was in spice, like the wood stock would oversaturate with moisture in the jungle conditions. The jungle was too dense. Was more too dense for that long rifle to go through. Also, some of the design issues was uncontrollable and fully automatic fire. The rifle round was too heavy. The rifle itself was heavy because you're looking at about 20 rounds for 20 pounds, and the amount of ammunition that was carried was not sufficient enough. So after about a year, they pulled it in favor for the M16 that actually met the demands that were required because it didn't use a lot of wood, cause issues. I mean, even with the AKs, you still had wood, but it wasn't a lot of the time. It would still work. The stock of the M14 was actually part of the actual structure itself.
So then once the equipment got introduced in the field, it quickly became apparent that it needs some changes.
Yeah,
I think we see parallels with that with exoskeleton technology. So that on the other hand, in the field, it sounds like there's a lot of manual labor where you don't have access to forklifts or other ergonomics equipment. What is that like?
So I had the opportunity of deploying in 2007. I was force protection in Kandahar airfield. So we were doing convoy escort duty. So protecting convoys going at port observation bases. And that was the one thing I can say about the U.S. military's logistics. You guys had air dominance down to a pad, down to an hour. Easily get helicopters in and out of any location. Pilots, the U.S. pilots were amazing. But seeing like megastructures like Kandahar airfield, where you have access to X, Y, Z amount of forklifts and equipment, and then you go into these forward operating bases, formerly known as fire bases, and that was part of a coalition logistic program too. So in these forward operating bases, you have enough logistics to run patrols and then run any kind of frontline activity out of. But these forward operating bases, you'll find a lot of your rear assets, but you also have a lot of frontline assets that get stored in these forward operating bases, like artillery and armored, as well as combat engineering assets. So the combat engineering assets also use a form of armor recovery, bridge construction. That's logistics. Then that's something that would be very important for exoskeletons because now you're trying to build a bridge in austere conditions rapidly.
So could you give us like just a little bit of blue sky, like if you were out there, as you said, on this forward patrol, what would be really useful? I mean, because I understand it's got to work well, it's got to be useful,
yeah,
and people need to want to wear it. We've heard these conversations and things. So kind of give us some things like if you were sitting at the board of directors of Exo company, and you're just sitting there and you're a consultant, and you said, okay, these are things that need to get done and done right. What do you think?
Okay, so I got this. And you know what, Carl?
Carl Zellick, maybe? Or
Yeah, Carl Zellick. Okay, so Carl Zellick had made a comment to one of his posts on LinkedIn, and I said the words, "If it looks cool until you have to go to the bathroom."
right. Okay.
It looks cool until you have to go to the bathroom. If you're trying to get soldiers to wear equipment like this, and make sure that, like, because if we get a load of sea containers, yes, you have forklifts that are available. What you can't really drive a forklift into a lot of these sea containers. So this is where exoskeletons can really come into play, going in and out of these sea containers. These sea containers get bad or either rather hot or rather cold. And if I'm going to be wearing an exoskeleton that's going to give me the ability to lift this all day, every day, is it going to keep me warm or is it going to keep me cool in these kind of environments? That's something I would love to see. In Afghanistan, or before I was a tanker, I talked to several other tankers while they were in Afghanistan. They were issued what was called a chiller vest. You wear the chiller vest inside the tank, and it would keep you cool. But if you wore it too often, you could get hypothermia from it. It was just why it was either one extreme or the other. Yeah, mind you, this is back in like 2007, 2010.
Okay.
So things have kind of changed a bit. And is it easy to don and doff any kind of other personal protective equipment that I may need? So I do have to wear some sort of personal protective equipment like body armor. Am I wearing it underneath, or can I quickly doff the exoskeleton and get my equipment on? That would also be rather nice too. And also being able to go to the restroom with it. That's always been a struggle with equipment from day one. Whether you're bound up for the winter and you're wearing 4 layers, or is extremely hot and humid ever, and the moment you take your shoes off, it becomes a nesting ground for bugs.
So it's amazing that what we are hearing is there's some things that we have heard multiple times from industry, be it a factory or a warehouse. An employee has a 10-minute break. They need to don and doff the exoskeleton. Who's paying for that time? Is that coming out of their break time? But we're also now hearing new things like, if I have body armor, is this going underneath or over the body armor? So it's fascinating how there's connections and there's overlap and how there's unique challenges.
I do agree. Like, even on the website, things are you have everything broken up into different groups. Like, I can see a lot of transition coming from the recreational exoskeletons over to the military side, or even in certain industrial. And was it not the Steam Mojo, but was the Sea Mojo? It was the exoskeleton that took the shock off your knees if you're on boat.
Yeah.
Yeah, I think it was the module, but I can't remember its name. It's not been in development, I think, for a few years now, unfortunately. But that was a great example of a recreational consumer exoskeleton, the technology trying to transition to defense use.
Yeah, and even industry. My father's a commercial fisherman, and hearing them, like, there's a lot of people that work on boats that get bad knees after several years. Now, how can you have that same concept, but the same concept that you're trying to get the military is like, can I get final control? Is this thing going to save my life in a disaster situation? If I go overboard, can I quickly get this thing off, or can it help me float?
So a lot of similarities there. I want to ask you, we've obviously seen in film and television and science fiction a lot about combat exoskeletons, where you have the exoskeleton and you go into a live firefight. And we've seen from a practical point of view a lot about logistic exoskeletons that help with logistics and supply for defense, and like you said, in these forward military operation posts, or what used to be called fire bases, where you wouldn't have necessarily access to forklifts and other equipment. Are we missing are we missing something here in the conversation? For example, you touched upon several times on maintenance. So would exoskeletons for maintenance be a separate topic that is neither logistics nor active combat?
You could roll maintenance into logistics, because once you start getting replacement parts in from logistic lines, and you can start fixing your equipment. But the thing that I might have forgotten about with maintenance is the time frame and the repetibility of fixing or doing maintenance. I mean, even if we're talking about rebonding up a tank, you have one exoskeleton that could replace maybe 3 guys. But when it comes down to maintenance, you're going to be working with certain carcinogenics, like what I mentioned with the running replen, was you're dealing with those lubricants like coolant, diesel oil, diesel fuel. Because once they'll start getting on the equipment, you may start having issues with the harnesses, with how it's mounted into the system, how it's mounted to the body. It may start getting absolutely messed up just from the amount of contaminants that are in the machine itself. Because what a lot of people don't know about tanks is that there is no real way to drain what's in that vehicle's hull. It's not like a car where it just jumps right on the floor. You have it's just a pool, waste oil, fuel, and other unwanted fluids, because there's no bathroom in tanks. It's not a good life to live. It's not a really good life to live, but when you have to actually maintain these pieces of equipment because of what they're used for, and it's like, okay, you really got to have a set of tools that can take the grind and the crud of working there. I guess a great example was the mechanic slugs. You may see some people wear their fancy looking tactical gloves that says mechanics on the knuckle. Those are actually really bad for working on vehicles because they just soak up diesel fuel and fluid, and your hands just become this mess. And also pulling off a glove is just, you'll get rashes just from that diesel soaked material. It's not, and that's where that's where when I say, well, at least within the maintenance area, you can address that by replacing those components. In the field or on the front lines, that's where trying to replace something like a harness is not as easy, and you kind of have to improvise or find something that you can do to fix it with whatever means necessary. Rubber bands and tape are kind of the infantry's go-to when it comes to trying to fix something on your clothing. And the one thing I can see a lot of infantrymen, let alone people on the front lines, not like exoskeletons, is if I get injured, can I get a trinket over the exoskeleton? Is there first aid applications that I can use? So if I do hit a landmine, can I use that exoskeleton as a bar to immobilize the body to get that patient out? Can an exoskeleton help me with walking wounded? And if I have to cut the clothing off the individual, is the exoskeleton going to get in the way?
Right.
And those are immediately those are the things I'm kind of thinking of. But the newer threats that are on the field, and talking to my friend who came back from Ukraine, was drones. They're everywhere. Could exoskeletons be a baseline for anti-drone issues, for anti-drone technology? And this is kind of coming back to what bionic power. I don't know the name of them now, but when they're scavenging energy, I mean, if you're running an ECM, that's creating a countermeasure, but you still have to carry the equipment, and you still have to power the equipment, especially if you're running up and down trench lines, only doing minor movements.
So it seems like we need to add even more weight now on soldiers who are already overburdened as they are. So in your experience, where have you seen people get injured? Like you yourself got injured, which ended your career. Obviously seeing film and television injuries in active live combat is very dramatic and very flashy. But it seems to me that the majority of injuries happen in logistics, maintenance, and training. Is that really the case?
It is, and because when you do have to do this repetitive training over and over again, especially when there is demand for deployments, because you always have to be prepared, for lack of a better phrase. And during that time, you're always pushing your body to the limits. You always have to realize that, okay, warfare is not gonna. They're trying to replicate warfare as similar as they can without actually completely destroying you. But it is hard on the body. I'm not gonna lie, it is hard on the body depending on how long you've been in, say, a job like any combat arms trait, infantry, armor, combat engineer, artillery. They all have their issues, because now when you're not doing anything, you're in the rear looking after your equipment. So looking after something like an N777, an artillery piece, now you have to clean the gunnet, replace the breech. That breech is probably over 300 pounds to pull out. So now you're looking at small stuff that you'll need about 2 or 3 guys to maintain on large systems. But the one thing I can see exoskeletons really pushing is getting wounded soldiers back into the field. Now, when I got my leg broken in a tank turret, I was working logistics for a while. So I helped my regiment with serialized equipment. So anything with a serial number, I was the one tracking it down. So it gave me a bit of an experience on how certain logistics work, at least within the Canadian military. But the U.S. military is a giant when it comes to logistics. But how can we put wounded soldiers back into a career where it keeps them going to, say, at least in their job, until they can find something else within their career? How can exoskeletons get those people back to doing the job? Not so much getting them out to the front lines, but to pull them back from the front lines to assist with the logistics. That's one thing I can see exoskeletons really driving that, because why waste talent of manpower when they're pulled off the front lines, because you can use that talent in the rear. But as for getting wounded on training's the best, in my opinion, training's the best way that you can finite equipment before you deploy it. And this kind of goes back to the M16 and M14 conversation is never try to use combat to actually test your weapons or your equipment. It happens, but a lot of times you'll have to replicate that through training. And I mean a few years in training with one group, and they're running the equipment till it finishes off. That's when you can the military will give that blessing, like, yeah, we're taking it. And then the other thing too is that when the military likes to buy something, they like to buy it once. So how long can they get it? How much light can they get out of one frame?
Yeah.
Let alone one motor. But as for seeing exoskeletons preventing injuries, I can see the injuries being prevented if there's some first aid applications with the exoskeleton. But in training and doing logistics, and like I mentioned before, working on heavy tank equipment, heavy tank parks, like that's backbreaking the law as it is. Replacing something like, I wish I had actually, now that he mentioned about not having visuals, I wish we had a picture of a leopard. I can tell you the weight of one component that needs 4 people to get, separate from what I mentioned before. It's a drive sprocket, and we need about 4 people to haul that thing off, or the drum that attaches to the drive sprocket. Now, also, there's talks of moving over to drone tanks. So, or the newer Abrams A3 has only a 3-seat crew. So that takes one person out of doing any kind of maintenance on a vehicle. So if you have an armor recovery vehicle with an exoskeleton in the back, you input-output, connect that to the vehicle, and you could work on a down tank or a down equipment a little bit more efficiently. So whether it be a drone tank or some of the newer tanks with only 3 crews, with only a 3-man crew.
Yeah, that's an important point. I never thought of that, which is like, if you have less people in the tank, that's, fantastic for the army. But with brakes, you got less
people to fix it.
You have less people to fix it. And if it takes 5 people to like fix the tank tread, and you only have 3, you're in, trouble. Huh.
Yeah. And this is where that input-output would make. Now, because you have that added power, because what was it? Over 3,500 horsepower. Yeah, 3,500 horsepower, I think, coming out of that one tank. So you're generating the electricity you need to power. But what was the Hardyman project from GE? It was like a 1 to 15.
Yeah, I don't remember the exact. I don't remember the exact needs of it, but it was certainly the very first device. And there's some people I think, right, Bobby, at ASTM, they're looking to try to find tons and tons of information about that and kind of restart that.
Yeah, Matt Dickinson has an entire YouTube series on rebuilding 190-man park on the 70s and the 80s.
But just to kind of get back, just to see where we've come, right? We came from there, and then we built some really outstanding systems in the 90s. Then we've gone to kind of smaller quasi-active, quasi-passive systems. And then, I don't know, maybe we need some fancier systems back again, right? If you making this up for a second, but if you had like 5 drone tanks but they get busted and broken, you're going to need, 5 or 6 really highly qualified people to get them up and running again.
And when I mentioned about pulling any individuals get injured or pulled back from the front lines, with the exoskeletons are providing them that relief when it comes to actually doing even that physical labor, that gives them more employment to do these kind of jobs.
Mhm.
Yeah, it doesn't escape you from the fact that you're going to be waking up at 4 a.m. and it's freezing out and you haven't showered in days.
Yeah.
But when you have to put on an exoskeleton, it's like, okay, does the eater work? Cool. Turn it on.
Right. Yeah.
I mean, I wear an exoskeleton in the field all day if it has an onboard heater.
Or you're saying in Canada? Yeah. Okay.
Oh, in Canada, or because not a lot of the vehicles we had overseas had any AC at all. So we had a South African mine-proof vehicle, no AC in it at all. But we also needed a hydraulic ram to help us open up a door. So that was the amount of armor that we were dealing with. And this is where exoskeletons, I wish, were available when we had to fix stuff like this, or even changing a tire. The U.S. Striker, an infantry fighting vehicle / APC, one of the tires on it is, it's probably up to Bobby's chest. It's that big. Or up to my chest. It's rather a big piece of equipment. You can do it with one person, but ideally you want 2 people to do it.
Yeah.
And if I understand correctly, people are getting injured because right now you have to do that maintenance on the field. You're either a sitting duck or you have equipment that's not being used and utilized.
And the ground's not always going to be level either. So this is an important factor. And this is where you're going to get injured. So if you're hauling equipment across a field, it's not going to be like a parking lot. It's going to be grassy, full of tank ruts, problem mud, and it's going to be uneven up and down. I'm not trying to pull the grandfather talk that I walked 40 kilometers uphill and downhill to get to school, but people do exaggerate.
Yeah.
But all comes down to those maintenance areas where they're set up for the logistic matters. Now, but as for other stuff with logistics, like bringing in supplies, back to your question, Tom, about loading and offloading the planes, where you just have to get the guys in there to push that cargo so it's tight. Once the forklift comes in, you can get one person with an exo, maybe 2 person depending on the cargo load, and just guide it back in, lock it in, guide it back in, lock it in, and then once they're done of loading, they can just hop off the flight or hop off the aircraft and load themselves back on whatever vehicle, or load the exoskeletons on whatever vehicle they came on.
Yeah.
But also with going back to, actually, this might be an interesting topic. Can exoskeletons benefit people with prosthetics?
Yes.
So, yes. There's some people in Europe that were using a hip exoskeleton to assist a passive prosthetic ankle, or maybe a hip exoskeleton to assist a powered prosthetic ankle. And so people are some nice work in that area. But that's where we talked, I think, in our episode when we were talking on the medical arena, what is a brace versus what's an exoskeleton versus what's a prosthetic. There's a lot of crossovers. And I think where we're getting there is mobility, right? I mean, people just, need to be able to walk, need to be able to push, need to be able to lift. And, how can we create tools to make that easier, right?
There is one important thing that I'm missing on this, Mick. You just remind me there, Tom, is the simplicity of the interface for the soldier. If the soldier is not capable of understanding the interface quickly enough, I mean, I've been in situations where I have to just figure it out on the fly. Not to say that it has to be that way, but if the system on an exoskeleton is simple enough that the person donning it or using it can easily use it without having to go through a week's course or even have a day's training. I mean, that's kind of the ideal thinking of the matter. But starting off, you're looking at probably a 2-week training if these things are going to be implemented.
Yeah. I mean, I think we talked about this before too, which is, Bobby talked about it, which is you need to wear the device and learn how to use it. Like we talked about this, like riding a bike. You don't just get on a bike and ride. You've got to maybe take the 1 or 2 weeks to learn how to use it. But on the flip side, I 100% agree. When we were talking to the Air Force, they were telling us, look, it's got to be simple. Someone's got to be able to put it on fast, use it, take it off. This reminded me of a story too. They were saying, like, you got to be able to run with this device, right? Because you're in the back of the airplane and maybe the airplane needs to take off.
Yeah.
And it needs to take off now. They don't, they're going to start taking off and you've got to just run out the back, right? So there's always these, I think, stories of like, I think where the military challenges everyone the most, because you're not working in the parking lot. You're not working in a nice manufacturing plant that's got air conditioning, or not all of them do, but you've got to be able to work in a tough environment, and it has to be able to work in emergency situations.
I do agree, which leads me to this one point. More than likely, and this kind of breaks my heart too, because you never want to hear this about, something so nice. It's going to be disposable. Why I say that is I've seen people even when they go out and they buy their own body armor, it's nice, it fits great, but in the end, it's meant to get shot. It's meant to get destroyed. And that's the one thing that I try to avoid the frontline work, because this kind of equipment's meant to be destroyed. And ultimately, and when I talk about the logistics and the maintenance side of the house, like at least that allows the equipment to be more preserved and observed for any kind of deficiencies. So unlike a rifle like an M16 or an AK, I don't care about the gun. Like, does it work? Cool. Do I have to get rid of it in a heartbeat? Yes. I guess an example of that was, and I'll use a weapon for an example. Private military groups that were working for anti-piracy. If they were going into a port that does not allow weapons, they throw their weapons overboard because they're not allowed in port, or else they'll have the police on them. So they'll take off whatever equipment's on the weapon they can keep, like the optic or a sling, and then the whole thing just goes overboard. Magazine, guts, and all. And that's where I kind of, when we would want to talk about like use in the front line, going up and down a trench line and wearing an exoskeleton, or going through the field on a reconnaissance patrol with an exoskeleton. If we have to get rid of it, we got to get rid of it. Even our reconnaissance group, speaking of reconnaissance, we have armored reconnaissance. When we're setting up our surveillance suites, which weigh a lot, they're connected by a fiber optic cable that's spooled out of the back of the vehicle. So you can put a camera out in the field, have the vehicle parked somewhere else, and then observe the field. This is pre-drone technology. But yeah, so the standard operating procedure was that if we ever get bumped and we can't get the stuff back, we cut the cable and drive off. And that's why I didn't really want to talk too much about exoskeletons in the front line, because ultimately they have to be reliable and disposable enough for the front line. While in logistics and maintenance, you can keep them around and have more benefits.
Well, you're a treasure trove of information. I would highly encourage that companies consider hiring you for consulting. I have touched upon these, but it's completely different to have your perspective from the field, and the fact that you have studied bioengineering, biomedical engineering. You understand these things. You know how to make these connections. So this brings me to my last question for you, which is, how should we communicate about this technology? Because I think like even the exoskeleton report is a little bit highbrow, and it helps for you to have some science and engineering background in order to be able to read the articles through it. How should we communicate to both officers and people that are in the field doing the work about this technology?
I think I know we had this conversation before, Bobby, about the fiction about exoskeletons, and the reality is that most people when they go in the military, they try to keep their expectations high, but in reality, the expectations low, because they think they're going into Hollywood, or they think they're going into obviously it's life-changing in ways, but not in the same way that is sold or romanticized. To understand the use of exoskeletons, like for soldiers to adapt in this kind of technology, like I mentioned, is like which group are we going to talk to? Are we going to talk to people who are going to be on the front lines, the infantrymen? Special forces guys may have a budget for this kind of stuff because they're always going to have a higher performing. So they're going to try a lot of exoskeletons before they get disposed of, but to the front masses. But for the logistics side of the house, and actually this is one individual I wanted to bring on a podcast. He runs Task and Purpose. He's a military Annie, former infantry, he's former U.S. infantry. So he mentioned a quote, but it's amateurs talk tactics, professionals talk logistics. And that's where you're going to start getting a lot more education. In my opinion, you're going to start getting a lot more education with soldiers is through the logistics, is through those logistics chains, is through the maintenance chains. And then if you're going to start getting the ideas from, or if you're going to start getting help from the people from the front line, like infantry and armor, that's where you're going to start seeing a lot more interest coming from the front to the rear, because you're always going to have a surplus of manpower on front. So any manpower that's brought from the front to the rear can be utilized, and that's where you're going to start seeing a lot more exoskeletons, and that's where it's going to be, where everything is going to be placed. I'm not going to say that you educate like walking into a Walmart where you always go right and then go around left to the cashier, but it has to be set up in a way that the technology is going to grow and develop before it gets to the front line. The reason why, and that's not an unknown practice. Originally, the M4 rifle was made for rear echelon troops. It wasn't until the global war on terror where you started seeing frontline soldiers use them. So it's just a place where that technology can develop. And the only reason why I bring up weapons, because like medical equipment, if that system's not in check, the end user is going to be in trouble. So whether you're a doctor or you're a soldier and your medical device or your weapon doesn't work, or the interface is completely out to lunch, it's not going to be any good for anyone, at least in your situation. I guess that would be my perspective, how to educate more soldiers into that, is that where is the exoskeleton technology being adopted within a military group, and during maintenance and logistics is probably your best bet right now, and also backing up newer technologies that are coming to the front, like mentioning drone tanks or larger field drones. I don't know if there's one available that someone attached a mortar to, but that's huge, and that's when yeah. But then you can start seeing exoskeleton technology creep out to the front line.
Like to support weight in battery requirements for personal jammers is one example you gave earlier, which I thought was a really good one.
Mortars, 80 millimeter mortar teams, machine gun teams. There's a bunch. Forward communication array, forward communication setup, ECM vehicles, anything you could stick on a vehicle, I can see an exoskeleton coming with you. If it means like you got to dig in, or dig in, I mean you got to set up a lot of equipment or deploy a lot of equipment. But as far as like the individual infantrymen running around, hip exoskeletons would be great if it could find a way to attach it to the body armor, so you can just dop at one go. But that's just me spitballing now. But in that, yeah, it's just a matter of like time and application where they adopt them, because it has to start somewhere from someone.
Wow, fascinating. What a great conversation. Tom, do you have any other questions for George while we have him here?
No, I think that was an excellent podcast where we were really just trying to understand where exoskeletons can be used and understand the need, and really try to educate people on how tough some of these jobs really are. And I think you said it once, Bobby, where it's like, we could have some sensors beeping and telling you not to twist, but it's like, no, we got to pick up, as you said, we've got to pick up, 4 people have to pick up a giant gear that's inside of a tank, or one treads 80 pounds, right? I mean, some of this stuff is just heavy, right?
Yeah, it's a lot of heavy, demanding work.
Yep.
There's a few like minor things that I mentioned that I don't think I mentioned was, now that night optics are getting more popular, that exoskeleton gonna present any IR signature? Can I shine a flashlight on it and all of a sudden, hey, your suit glows in the dark under night vision? can it help with your thermal profile? Now that thermal imaging is starting to become more readily available, is it can reduce your thermal profile? But also can it help carry the weight on that? Can it help carry that extra weight or even power the equipment that you're using? There's so many factors for the front line that have to be taken into account. And I mean, I'm only one guy just throwing stuff at them in their head. But working in maintenance and working in logistics is like there's a lot of heavy organizing stuff because you're gonna have to make room rapidly in areas. Oh, I didn't mention this. Medical. This is where I know we weren't talking about medical, and it just dawned on me. The use of the roll-free hospitals or layered hospitals. Japan has been using exoskeletons for patients, but a roll-free hospital, if you have walking wounded or if you have patients on a litter, will exoskeletons benefit you in a roll-free hospital? Again, this is going to be like a not very nice looking hospital. This is probably going to be put next to a burnt out building. Your diagnostic imaging lab may be being run off a generator from a sea container. I've seen a CT imager, like an entire CT suite inside a sea container, and an MRI. So that gives you options for use of exoskeletons in a medical field without it being medical. So moving patients, moving the equipment around in these kind of very small, austere conditions that getting a forklift or having the manpower may not be there.
Yeah, and we are seeing more and more, especially from Europe, medical staff using occupational exoskeletons within a medical setting to move patients, to move equipment, or to perform long surgeries and procedures. I have to say, it never even occurred to me that this is a triple application now, where it's an occupational exoskeleton for a medical setting within the context of the military defense and a field base. This is like really taking it all and bringing it back together.
Technologies, when humans connect to technology, there's always a duality to it. You know, you can always look at the good and evil, but never really like, oh, I didn't know that my German my Austrian G-Wagon would be a luxury vehicle at one point. It's funny. I don't know why I brought that up. It's just funny. Some things that usually have a military application will eventually find application somewhere else. The BV209 is a Swedish vehicle. That's what I was trying to get at. It has a bunch of track. It was actually meant to be used in World War II, and now it's used for both search and rescue in Arctic environments, swamp, and also can be dual use firefighting, and it can float. So it's one of those vehicles that you look at and say, man, this thing's stupid. It's never going to work, and then it just proves itself. Just not many people see it because it looks ugly.
I'll have to look that one up.
Oh, it's just two boxes of track. It looks ridiculous. Our military use them. The U.S. military used them at the close to the end of the global war on terror because the vehicle is light enough to actually drive over sand dunes. What are the exoskeletons going to be made of? Fiberglass, polymer, metal? No one wants to carry it. And I mean, what kind of metal?
Right. Yeah.
The kind that gives the intent a shot.
Yeah. Well, that was great. That was great. I really enjoyed the conversation. I think I hope the listeners really enjoyed it and got a really good sense of what it means to deploy exoskeletons in military applications. Thank you, George.
Thank you so much for your time. Really appreciate you being here and talking with us and our listeners. You're just an encyclopedia of information.
I appreciate you, Bobby, and thank you guys for having me and having me ramble on about my experiences and views on exoskeleton technology. And I hope to be on the podcast again with you guys eventually in the future.
We will be lucky enough to have you. Absolutely. Thanks everyone for listening to episode 9 of the Exoskeletons and Wearable Robotics podcast. We will see you again in 2 weeks. And thank you to all of our Patreon supporters.
Please consider supporting this podcast, this exoskeleton report, the catalog, and the work we're doing. You're doing work that others aren't willing to do. You're building the catalog, you're educating the community, and it needs to be done.
Yeah, but Tom's right.
So I think that's where I would end it. I would just end it as, please support the work that I'm doing in this field.